All right, let's try another chemistry problem. So a chemist has one solution that is 80% base and another that's 30% base. What is needed is 200 liters of a solution that's 62% base. The chemist will prepare by mixing the two solutions on hand. How much of each should be used? So we have volumes here in liters, so I'll put that up there in parentheses. Our weak one is a 30% base. And our strong one is a 80% base, and then we want to get a 62% base, and we have to get 200 liters of this. And so what we're asking is how much of each of these will be needed. Well, of course, we're going to say X and we're going to say Y for each of those, and then we are going to use the fact that volume times percent is equal to the pure, and these are bases, and you see I've put that in there. So we have 0.3X and we have 0.8Y. 0.8y, and after we have that, we have multiplication as well. Here we have 0.62, that's our percentage as a decimal, remember, times 200, and I usually do simplify that in the table as well. I do need to write down what that came from though, and that's equal to 62 times 2 is 2 times 2, which is 4, 6 times 2, which is 12, and then the 2 zeros there, and then I need the 2 decimal points. So there we have it. Now why don't you go ahead and pause this for a second, see if you can write the two equations, and see if you can solve them. Okay, maybe you took a quick little sneak peek here to see what your equations were, see if you got them right. If you did, go ahead and pause it again and see if you can solve it by yourself. Okay, so looking at this here, I cleared the first equation, or I cleared the second equation of decimals, and then I added them together by multiplying this first equation by a -3. And I solved for y, I solved for x, and then I wrote this as 128 liters of 80%, and I wrote it as 72 liters of 30%. Don't just write that x equals this and y equals that. Do specify on that. Now let me put this in just a little bit of perspective for what this means. Basically, what we're doing here is we're taking a bunch of the strong stuff and then we're dumping some of the weak stuff in to dilute it. And we're diluting it so that we will get this 62%. All right, now here's a little tricky of a problem, number 37. How much water should be added to 30 gallons of a solution that's 70% antifreeze in order to get a mixture that's 60% antifreeze? What you need to understand in solving this one is that water is 0% of anything. So with that said, why don't you go ahead and pause this and see if you can write the entire table up for yourself, come up with the equations and solve it, and then come back and check yourself. All right, maybe you've taken a little sneak peek to make sure that you've got yourself on the right track, right? We have water, which is the weak, which is X, and we're adding that to the strong, which is 30 gallons of it to create a mixture, which we don't know how much that'll be. The water, the weak stuff, is 0% antifreeze, and the strong stuff is 70%, and the mixture we are creating is 60%. So we multiplied straight across. Volume times percentage is equal to the pure, and so 0 times anything is 0. 7 times 30, 21.6 times y to give this. And so we get our equations, x plus 30 equals y, and 21 is equal to 0.6y. And then we can solve it. So you go ahead and see if you can solve. Okay, so I use substitution to solve this one. I'm substituting from the first into the second equation. I solved that all the way down till I got 0.6, x is equal to 3. Then I cleared at that point by multiplying both sides by 10, very easily giving me that my x is equal to 5, which means I have 5 gallons of water that's being added. Keep in mind that this means that we're taking this strong antifreeze solution and we're diluting it, right? We're making it a little bit weaker. See that we're making it weaker. And 5 gallons of water is my simple answer, and then I did check my answer. X plus 30 is 35. 35 times 0.6, is that equal to 21? Absolutely. All right, our next conquest is simple interest problems. So we'll come back in the next video and we'll be doing simple interest problems.